Alright, so today we're going to be talking about graphing inverse variation functions and its key features. Just like with any other function, we do have a parent function, so that's y equals 1 over x. Wonderful fraction, we love it. So, the table. We have these selected x values and we want to find the y values. Remember, with y values, all you got to do is plug in the x value. So over here with x equals -2, I'm going to plug it into this equation here. I have x 1 over -2, so that means that we have -1/2. Here we have 1 over -1, which is just -1. 1 over 0. What did we learn? We cannot have that. That is going to be DNE, undefined, whatever you want to call it. Alright, and then we have 1 over 1, which is a +1, and then 1 over +2, which is a +1/2. We can find all of these points except for the does not exist one on our graph to the right. We have 1, 1, we have -1, -1. We have 2, 1/2, and we have -2, -1/2. So the next thing that we need to talk about with this is the domain and range. It's not written on your notes, but it's something that we need to talk about. So domain and range is related to the parts that don't exist. That's what we're going to be putting in as our numbers and infinities. So the two ways that we can write this is -infinity to 0 union 0 infinity. Because if you look, remember domain is this part. I re-highlighted it. It's this part. So whatever it doesn't touch, and it never touches that 0 if you notice. It gets really close, but never exactly. Alright, and then with range, it's the same thing. But it's going to be the y value. So you notice that it's never going to touch its y-axis. So that means it's never going to touch 0. So that means we're going to have -infinity, 0, union, 0, infinity. That's how we're going to be writing these. Alright? And I'll show you another way to write them at the very end, but let's keep going. So a couple of things I want to talk about is that this is called a hyperbola. It's like a parabola, but it's not continuous, so that's why it's called a hyperbola. It's not a hyperbola, it is a hyperbola. Alright, so these hyperbolas have what's called asymptotes, basically where it will never touch a number. So we have two types of asymptotes, and that is a horizontal asymptote and a vertical asymptote. The horizontal asymptote is the top and bottom branches. So that's where it's going to be a horizontal line that just kind of cuts it in half and will never touch those lines. So it's going to be what y value will be that. And then vertical asymptote, that's the left and right branches. So that's why it turns into these two corners here, because we have a top and bottom and we have a left and right. So the vertical asymptote is going to be related to the x values. So what makes the denominator 0? So in our case, it was 0 for the parent function. So horizontal is y, where vertical is x. And then we have the intersection of asymptotes, pretty self-given. It's just h, k. Wherever they intersect, that's your point. So for our parent function is 0, 0. Alright? And then you know x and y intercepts where they cross those certain axes, and we write them that way. So let's move on to our first example. So we have y equals 1 over x plus 2 minus 3. First things first, we want to find some information before we can graph any of it. Horizontal asymptote is going to be found with this guy, whatever number is on the outside of that fraction. So the horizontal asymptote is y, so we're going to do y equals -3. I can graph that real quick right here. That is my horizontal asymptote. Alright, then my vertical asymptote is found by the denominator. It's found with x. So that means we're going to have to do x plus 2 equals 0, x equals -2. Whenever x equals -2, that will be our asymptote. So that's what I'm going to write. So it's this line right here. So now we have our intersection of asymptotes, which we found to be -2, -3. So now we know a little bit more information about what this is going to look like, but let's solve for those x and y intercepts first. If you remember, to find an x and y intercept just from an equation, all you're going to do is plug in 0 for x or y, depending upon what you're solving for. So for x, we're going to plug in 0 for y, and then we're going to have 1 over x plus 2 minus 3. Solving for that x, we get +3. 1 over x plus 2. Solving for x, we got to get rid of that fraction. So we're going to multiply by x plus 2. we get 3x plus 6 equals 1. Subtract 6 from both sides, we get 3x equals negative 5. Divide by 5 to both sides, we get x equals negative 5 over 3. So my x-intercept is negative 5 over 3, comma 0. So I can go ahead and graph that real quick, which is going to be negative 5 over 3 right here. So let's do the y-intercept. The y-intercept is going to be the same exact thing, but now we're going to plug in 0 for x. So we're going to do y equals 1 over x, 0 plus 2 minus 3. That reduces down to 1 over 2 minus 3, which is going to be negative 5 halves. And if I go ahead and graph this, that means it's going to be right about here. So I can now graph this guy, and I see this is my branches. So let's talk about that domain and range real quick. So domain is going to be related to the the vertical asymptote, because you know it's x equals. So if that is the case, that means we're going to do negative infinity, negative 2 union, negative 2 comma infinity. Range, just like domain, it's going to be related back to that asymptote, but it's going to be related back to the horizontal asymptote because that's where y is. So we're going to have negative infinity to negative 3 union negative 3 to positive infinity. That is always how you're going to write it. Just know your asymptotes and you're good to go. All right, let's do this second example. All right, so we have y equals 2 over x minus 1. So first things first, we got to find those asymptotes. So I find my horizontal asymptote based on the number that's outside of my fraction. There is no number outside of my fraction, so that means it's 0. So we're going to have y equals 0. So I'm going to go ahead and graph that. It's the x-axis. How fun. So now we have the vertical asymptote that's found with this denominator of x minus 1. So we have x minus 1 equals 0, so we have x equals 1. And that is my vertical asymptote. So let's go ahead and graph that as well. Bada bing, bada boom. We now have both of our asymptotes and we can go ahead and move on. We now know the intersection of asymptotes, which is 1, 0. How fun. So solve for the x-intercepts. This is going to be interesting. So let's go ahead and go. We now need to plug in 0. So we have 2 over x minus 1. And then for y-intercepts, let's go ahead and set up that equation. And we have y equals 2 over 0 minus 1. So what I want you to do is pause the video right here and solve for those x and y-intercepts and graph them. Pause the video here and go ahead and do so. Alright, if you did this correctly, you should have gotten confused by your x-intercept because that does not work. So whenever we have an equation that doesn't work, that means that intercept does not exist. And it makes sense because the x-axis is an asymptote. So we don't have any x-intercepts. Okay? And it's possible to not have a y-intercept either. But this time we did. We got y equals negative 2. And I just realized I wrote that wrong. It is going to be 0, negative 2. So now that I have all this information, I can go ahead and graph. So that means we're going to have something that looks like this and this. Not too bad, not too shabby. Alright, so then the domain and range, remember it's going to be related back to those asymptotes. So domain is related to the vertical asymptote. So that means we're going to do negative infinity to 1 union 1 positive infinity. My range is going to be related back to my horizontal asymptote. So it's going to be negative infinity, 0 union 0 infinity. Bada bing, bada boom. Let's go. So let's move on to the third example. Alright, we have y equals negative 1 over x plus 2. Alright, so I want you to find the horizontal and vertical asymptotes this time. Remember, horizontal is here and vertical is here. So pause the video right here and solve for those asymptotes. So if you found those asymptotes correctly, you should have found that it's y equals 2 because of the outside number. And the vertical asymptote is x equals 0. There's nothing else with that x, so x is 0. So I went ahead and graphed those two items. You know, color coding, you can figure it out yourself. Intersection of those asymptotes we have as 0, 2. Okay? So now we have to solve for our intercepts. So let's go ahead and set up those equations. So for the x-intercept, remember we have to replace y with 0. So we have negative 1 over x plus 2. And then to solve for the y-intercept, we have to replace x with 0. So we have y equals negative 1 over x, but now it's 0 plus 2. I noticed something immediately the second I started doing my y-intercept. It's over 0. We can't have that. So that means, this don't exist. We do not have any y-intercepts. So we can just go ahead and do the x-intercept. So I want you to pause the video here and find that x-intercept. So if you did this correctly, you should have gotten your x-intercept to be 1/2. So I went ahead and graphed mine, and you can see that on the graph right there. So let's go ahead and graph those lines. So we have something looking like this. And if you notice, it's a little bit different, but that's okay. So let's talk about that domain and range. Remember, domain is related back to the vertical asymptote because it's with x. So I'm going to make it green. So I have negative infinity to 0, union 0, positive infinity. Range, same idea, same exact layout, just a different number because it's now related back to the horizontal asymptote. So my range is going to be negative infinity, not negative 2, is going to be a positive 2, union 2, comma, infinity. Exactly how you want to write it. Don't change it. All right. Don't forget those u's. That is going to be the number one common mistake, is that you're going to forget about those u's. That has to be part of your interval. All right. So let's do this last one. So we have y equals negative 3 over x plus 1 minus 1 on that outside. So what I want you to do is find the horizontal and vertical asymptote yourself, and then identify that intersection of asymptotes. So I want you to, guess what? Pause the video here, solve for those 3 items, and then unpause when you are done. Alright, so you should have found that your horizontal asymptote was negative 1 because of the negative 1 on the outside of the fraction. You should have found that your vertical asymptote is x equals negative 1 because you're going to put x plus 1 equal to 0 and find that x equals negative 1, and that would be our asymptote. I went ahead and graphed mine, as you can see on my graph. So then the intersection of the asymptotes is going to be negative 1 comma negative 1. So now all we have to do is solve for the x and y and then find that domain and range and graph. So solving for the x-intercepts, doing what we normally do, putting that 0 in for y. So we have 0 equals negative 3 over x plus 1 minus 1. Solving for x, we're going to add 1 to both sides. So we have 1 equals negative 3 over x plus 1. Solving for that x plus 1, we got to get it out of that fraction. Nobody likes the fraction. So those cancel. We have x plus 1 equals negative 3. Solving for x, we're going to subtract 1 from both sides, and we get x equals negative 4. So my x-intercept is negative 4 comma 0. I'm going to go ahead and graph that. All right, so then I have my y-intercept. So we have y equals negative 3 over x plus 1, but now it's 0 plus 1 minus 1. So we now are going to simplify. So we have negative 3 over 1 minus 1, and then we have y equals negative 3 minus 1, so y is equal to negative 4. Very similar to our x-intercept. So we have 0 comma negative 4. I'm going to go ahead and graph that. So 0 comma negative 4. All right. So now that I have my x and y, I can now graph. So it's going to look something like this. All right. So now that we got our graph and everything else, let's go ahead and figure out that domain and range. Domain is related back to the vertical asymptote. So the vertical asymptote is going to tell us what number to use. So we have negative infinity and negative 1 from our vertical asymptote, parenthesis, union, negative 1, infinity. The range is related back to the horizontal asymptote. So you have negative infinity, negative 1, union, negative 1, comma, infinity. And that's it. All right, so I spoke really fast, so if you have to re-watch anything, just go to the YouTube video. All right, have an awesome day and stay safe, and let your teacher know if you have any questions.